Hello students, myself Pharmaceutics, Assistant Professor, School of Pharmacy, BBD University. Today's lecture topic is hydrophilic lipophilic balance from Physical Pharmaceutics 1. So what is HLB value and HLB method? It is based on the premises that all surfactants combine hydrophilic and lipophilic groups in one molecule, and that the proportion between weight percentage of between two groups is for non-ionic surfactants and indicates a behavior that may be expected and from the products. So here the surfactant and HLB value means HLB value is proportionally to the polarity of the hydrophilic head group. So what is the definition of HLB value? It is the relative efficacy of the hydrophilic quotient of the surfactant molecules to its lipophilic quotient of the same molecules. HLB Griffin scale. So basically HLB value is given by a scale measurement 0 to 18 scale, and which is given by a Griffin and also known as a Griffin scale. It is an arbitrary scale between the 0 and 20, 0 to 20, which expresses numerically the size and the strength of the polar portions relative to the non-polar portions of the molecules. Although originally applied to non-ionic surfactants, its use has now been extended to ionic surfactants. Here the HLB for ionic surfactants are much higher, up to 50, based on the ionization of the properties. So here the scale 0 to 20 and 0 to 18. Basically we studied a 0 to 18. 0 to 6, it is light the substances which having a hydrophobic or oil soluble substances. Between 6 to 10, all the substances are water dispersible. From 10 to 20, all are hydrophilic or water soluble substances. For solubilizing agents, the HLB values lie between 15 to 18. For detergents, the HLB value lies between 13 to 15. For O/W emulsifying agents, lie between 8 to 16. Here the wetting and spreading agents lie between 7 to 9. What W/O means water in oil emulsifying agents lie between 3 to 6. Anti-foaming agents lie between 2 to 3. Here the scales for HLB values is noted down. Aim of the HLB Griffin scales. Why we use a Griffin scales? Why we observe and determine the HLB scales? HLB approach is empirical, and it does allow comparisons between different chemical types of surfactants. Besides that, it provides a systematic method of selecting a mixture of emulsifying agents to produce a physical stable in the emulsion. The higher surfactant HLB value, the more hydrophilic it is. अभी जितना HLB value higher होगा means it is a hydrophilic substances. If HLB value is lower the surfactant, it shows a more lipophilic. Example of the surface active agent: fans are sorbiting fatty acid, each having a low HLB values ranging from 1.8 to 8.6. Here twins are polyoxyethylene derivatives of the span, so they are more hydrophilic, having a higher HLB values ranging from 9 to 9.6 to 16.7. Determination of the required HLB values and blending of the surfactants. Oils used in the formulations of emulsions require certain HLB values to be formulated as W/O emulsion or O/W emulsions. For the same oil, the required HLB value for O/W emulsion is higher than the required HLB value for W/O emulsions. Here the oils. In this table, we observe the oil and their emulsion types and their HLB value lies. If the oil is stearic acid, the O/W emulsion show 15, and in W/O emulsion it show HLB value 6. Cetyl alcohol show the 15 from O/W emulsions, and W/O emulsions is nil. The sterile alcohols show the 14, value is 14 in O/W emulsions, and in W/O emulsions it show nil. Mineral oils and lights, they show 12 in O/W emulsions and show 4 value in W/O emulsions. liquid paraffin 10.5 HLB value in oil in water emulsions and 4 HLB value in water in oil emulsions. So on, castor oil also is show a HLB value 14 in oil in water emulsion and nil in water in oil emulsions. These are some examples of oils and their HLB values lies between. Calculation of the required HLB for a mixture of oils and fats or waxes. Multiple of the required HLB of each ingredient by its fraction from the total oily phases. Add the obtained values to get the total required HLB for the whole oil phases. For example, liquid paraffin is present in 35%, bull fat present in 1%, cetyl alcohol present in 1%, emulsifier system या emulsifier agent is present in 7%, water to be 100%. So how we calculate this? The total percentage of oil phase is 37 and portion of each is 35 by 37 into 100 means liquid paraffin के लिए क्या हो जाएगा 35 given 37 is also given, so 35 divided by 37 into 100 it is 94.6%. For wool fat 1 divided by 37 into 100 it is 2.7%. Cetyl alcohol 1 by 37 into 100 it is 2.7%. The total required HLB number is obtained as follows. The liquid paraffin HLB value is 10.5. Means the formula put in 94.6 divided by 100 into their HLB value. HLB value of liquid paraffin is 10.5. So the result is 9.93. For wool fat is 2.7 divided by 100 into 10. 10 is their HLB value. The calculation obtained value is 0.3. Cetyl alcohol, it is formulated as 2.7 divided by 100 into 15. 15 is HLB value of cetyl alcohol. Obtained value is 0.4. So total required HLB value is 10.63 means plus 9.93 plus 0.3 plus 0.4 means total HLB value is 10.63. Calculation of the ratio of emulsifier to produce a particular required HLB value. अब हम ratios को कैसे calculate करेंगे for HLB values उसको observe करेंगे. One of the most important aspects of the HLB system is that HLB values are activated in the amount of each in a blend is taken into account. Thus, the blends of high or low HLB surfactants can be used to obtain the required HLB of an oil. The HLB of the mixture of surfactants consisting of fraction X of A, that is, and 1 minus X of B is assumed to be the algebraic mean of the two HLB numbers. Means formula is HLB mixture equals to X into HLB A plus bracket 1 minus X into HLB B. Rearrangement of the above equation in percentage formation. So we will be right also like this. A equals to 100 into X minus HLB B divided by HLB A minus HLB B, and for B equals to 100 minus A, where X is the required HLB of the surfactants oil mixture. So some examples, worked examples means you should be solved this. One is a formulated is required to formulate an oil in water emulsions of the basic formula, where the given is liquid paraffin is 50 grams, emulsifying agent is 5 grams and their HLB value is 10.5. The water is up to 100 grams. Calculate the fraction of twin 80 and span 80 and their HLB value is 15 and 4.3 respectively, used to produce a physical stable liquid. So how to solve it? For assume a twin 80 is a A and span 80 is B. So A equals to a previous equation is put here, and A equals to 100 into X minus HLB B divided by HLB A minus HLB B, where the X is 10.5. 10.5 is HLB value of emulsifying agent. HLB B means span 80 means span 80 का HLB कितना है 4.3 means 100 bracket 10.5 minus 4.3 divided by HLBA. HLBA 380 का HLB कितना है 15 minus 4.3. So A equals to 57.9%. For B, the formula is 100 minus A. So 100 and minus A. A क्या निकला अभी हमारा 57.9%. So 100 minus 57.9% equals to 42.1. So हमारा B कितना आ गया 42.1. And there A and B in ग्राम निकालने के लिए कैसे करेंगे? A 57.9 into 5 divided by 100 so equals to 2.89 ग्राम. 5 यहाँ पे क्या है? इमल्सिफाइंग एजेंट हमें कितना गिवन है? यहाँ पे 5 ग्राम गिवन है, इसलिए हम इसको इंटू करेंगे मल्टीप्लाइड विथ 5 एंड सेम एज B इक्वल्स टू 5 माइनस 2.89. 5 हमने यहाँ पे कैसे ले लिया कि जैसे 100 B का फॉर्मूला क्या था? B इक्वल्स टू 100 माइनस 8. तो B का फॉर्मूला कैसे हो जाएगा? देयर रिक्वायर्ड ये गिवन अमाउंट माइनस देयर HLB वैल्यू. HLB वैल्यू और A का ग्राम कितना है? 2.89 ग्राम. सो द B इज 2.11 ग्राम. Another example. What is the HLB value of the mixture consisting of 40% spent 60 and 60% twin 60? HLB is 4.7 and 14.9 respectively. तो यहाँ पे assume करेंगे हम A equals to twin 60, B equals to span 60. So the formula is A equals to 100 into X minus HLB B divided by HLB A minus HLB B. तो हम यहाँ पे हमें A गिवन है. A क्या है आपका? यहाँ पे twin 60 हम कितने परसेंट में twin 60 हम कितने परसेंट का ले रहे हैं? 60%. तो A क्या हो जाएगा आपका 60. यहाँ पे 100 गिवन है, 100 तो ऑलरेडी हमारे पास है ही. और X क्या है आपका? X आपको फाइंड करना है. HLB ऑफ B क्या है? स्पैन 60 का HLB वैल्यू इज 4.7. तो माइनस 4.7. HLB A का कितना है? 14.9 माइनस 4.7. तो हमें यहाँ पे X निकालना है. तो यहाँ पे हम उसको फॉर्मूले को रीअरेंजमेंट करके X इक्वल्स टू 10.82 निकल जाएगा. सेम प्रीवियस इक्वेशन और प्रीवियस फॉर्मूले से हम B भी निकाल लेंगे. तो हमें हमारे पास यहाँ पे HLB वैल्यू फाइंड आउट हो जाएगी. ठीक है. सो सम अदर इक्वेशंस आल्सो इन हियर. What is the HLB value of the surfactant plant consisting of the 20% spin A20 and 30% span 20 and 50% of span 80? Their HLB value is 16.7, 8.6 and 4.3 respectively. यहाँ पे हम A, B और C को लेके चलेंगे क्योंकि हमारे पास यहाँ पे 3 मिक्सचर्स हैं. तो 3 मिक्सचर्स का फ्रैक्शन कैसे हो जाएगा? फ्रैक्शन ऑफ A विथ HLB A प्लस फ्रैक्शन ऑफ B HLB B प्लस फ्रैक्शन ऑफ C HLB C. तीनों की कैसे हम फ्रैक्शन ऑफ A कितना है हमारे पास? 20 का 20% मीन्स 0.2%. 0.2 इंटू 16.7. उसी तरीके से रिस्पेक्टिवली और B फ्रैक्शन 0.3 इंटू 8.6. 50 का 0.5 इंटू 4.3. तो हमारे पास HLB मिक्सचर्स आ गया. अब सोल्यूशन B है ये हमारे पास. तो सोल्यूशन B में हम जैसे हमने पहले प्रीवियसली निकाला था X को डिफाइन करके फॉर A एंड फॉर B, उसको रिस्पेक्टिवली हम सॉल्व कर सकते हैं. Same problem 3. What is the HLB value of an emulsified blend consisting of 20% spent 20 and 75% twin 20? Their HLB value is 8.6 and 16.7 respectively. So practice this formula, practice this statements, problem statements. Problem number 4. And problem number 5. Thank you.